Good morning, everyone. Thank you for registering and attending this training webinar. We do a lot of training with our customers on a variety of subjects, but this is the first time we're doing it in this type of webinar format, and hopefully it'll be the first of many. I'll start by introducing myself. So my name is Scott Oakley. I'm the technical manager at Glasscorp. So a little bit about me, if you haven't dealt with me before. So I cover a lot of ground in my role. I look after the structural glazing projects where we supply Dow structural silicone. I'm involved in a lot of on-site testing and in-house testing of sealants, and I coordinate with our suppliers when there's a requirement for formal lab testing. On the compliance side of things, I maintain our safety data sheets and our test certs. And between all of that, I'm involved in responding to technical inquiries and doing trainings like this one. The focus of this presentation is weather and construction joint sealing application. We'll cover all different aspects of general sealant application, and I'll explain the ways in which Glasscorp can be of assistance for your specific project requirements. Just a little housekeeping before we start. So for the presentation, I will be turning people's microphones off, so there is no background noise. If you could see that yours is still on, please mute yourself for the presentation. We will have a little bit of time at the end for questions. So if you have any questions during the presentation, please send these through on the chat function. If I'm not able to respond in the moment, we'll have time to get to these at the end. If there's any curly questions or anything that I'm not too sure about, we will follow that up and come back to you. The presentation is being recorded, and we will look at making this recording available after the presentation in case there was anyone who registered or wanted to attend who wasn't able to make it today. With that all said, I will just turn my camera off and we will get ready to crack into it. Okay, let's get started. So we've divided this presentation into 5 sections, starting off with project management, on-site quality control, then moving into cleaning and substrate preparation, joint design and sealant application, and finally post-project requirements. Glasscorp are agents for a few large sealant suppliers, including Dow, Tremco, and Bostik. We also offer a range of Glasscorp branded sealants, which are made for us specifically. The sealant you'll be using on your project will depend on the application, what's been specified, and the types of properties that are required from the sealant. In the material that I'll be covering today, there may be some variations here and there, depending on the product being used. However, the fundamentals around proper QA, joint design, joint preparation, and sealant application should be universal regardless of the product being used. So in this first section, we will discuss common project management requirements that you may face. At the beginning of a project, it's important to know what is required or expected from you from a testing and compliance perspective. So here I'm not talking about your day-to-day QA testing. I'm talking about any additional requirements that may be set by an architect or a facade consultant. So the reason this section is at the beginning of the presentation is because it's important that you're aware of these and make us aware of any requirements on our end as early as possible, ideally before the project starts. You don't want to find out in the later stages of a project or after a project has already been completed that there's a requirement for a warranty when project records haven't been maintained, or there's a requirement for site testing when the building is already enclosed and no longer accessible. So to give you an idea of some of the requirements I'm talking about, adhesion testing is a big one. There may be a requirement to provide a formal lab adhesion report or a report for a sealant on a particular substrate. So the photo here is from formal adhesion testing done by a supplier. If you are asked for a formal report or wish to inquire about testing for a specific substrate, feel free to get in touch with us. There's a chance we may have already tested that combination of products before, and we might already have a report in hand. If it's a substrate that we haven't tested before, we can help facilitate lab testing with our suppliers. Often evidence of a simple site adhesion test or an in-house adhesion test will be sufficient, and that's also something that we can advise on and assist with. You might be asked for a report demonstrating compatibility between a sealant and substrate. Compatibility testing is something that's done in a lab environment. If you're looking to get testing done on a particular substrate, we can help facilitate this. The photo shown there is from a compatibility test done on a particular roofing membrane with several different Dow sealants. You could see the clear difference between the two sealants on the left from those on the right. The yellowing and discoloration you could see there giving a clear visual indication of incompatibility. And finally, warranties. While not necessarily a common requirement for most projects, particularly for weather and construction seals, they are available to us if required. Because a large part of the ultimate performance of a sealant will depend on workmanship and surface preparation and sealant application, warranties for sealants tend to be issued on a project-specific basis. The types of warranties available and the requirements needed to get one will obviously vary depending on the product being used. And I won't go into the specific requirements for each different type of warranty. That's a subject for a different presentation. The one point that I will make is the importance, again, of knowing what's required before a project starts. So some warranties will require us to carry out on-site testing to validate adhesion and joint fill, which is difficult to do if we only find out about it after the project's already completed, which does happen sometimes. In this next part of the presentation, I want to cover some of your standard on-site quality control tests, which you should be doing in order to achieve the best possible results. The peel adhesion test is the most effective way to confirm whether adhesion can be achieved to a particular substrate. We often refer to testing that's done at the start of a project or before a project starts as pre-adhesion testing. This is something that we always recommend as good practice. Now, this may be especially important when you're dealing with substrates that you haven't used before or that you're not familiar with, but I'll make the point that you're invariably going to have variation even within the same substrates from project to project. So these tests should be part of your QA program, even if you are working with the sealant and substrate that you've used before. And even if you have a formal lab test report, nothing replaces testing done in real-world site conditions. Pre-adhesion testing will also reveal if any specific cleaning or priming is necessary to achieve good adhesion, or if the sealant does not adhere to the substrate at all, and a change to the specification has to be made. So here I'll just cover the basic steps involved in performing a pre-adhesion test. So you'd clean and prepare the substrate to the required specification. You may want to apply multiple test layouts if you want to test different sealants or test different cleaners or primers, for example. Apply the sealant, tool it to form a uniform strip, ensuring that you're applying positive pressure to the surface. When we do adhesion tests, we like to apply 2 lengths of foam tape and apply the sealant in between just to give you that clean, uniform strip to test. Obviously, if you're doing this, make sure that the surface is cleaned and dry before putting down any tape. And importantly, mark or label each test section with the specific sealant, cleaning, priming, preparation that's being applied. You want to take note in the date of the time of the application as well. It's not very useful coming back a week after test strips have been applied if you don't know which one's which. So here you see 2 examples of adhesion tests that we assisted with. Both were on liquid applied waterproofing membranes. So the one on the left there was applied to a timber sample, which we did in-house. The one on the right done on a section of wall on site. So leave the sealant to cure, typically for at least a week, depending on the product used and the size of the sealant strip applied. So after the sealant has had sufficient time to cure, return and perform a peel test. Grasp a loose tab of sealant, pull back at 180 degrees in a slow and controlled manner. And while you're doing this, you'll be noting down the method of failure observed. Let me clarify what we mean when we talk about method of failure. If the sealant tears within itself and remains fully bonded to the substrate, this is called cohesive failure. So a 100% cohesive failure is desirable, as this indicates that the strength of adhesion is greater than the strength of cohesion. If the sealant pulls cleanly away from the substrate, this is called adhesive failure, and this is what we don't want to see. I'll note here that in the test, you could see a polyethylene strip has been applied to the substrate, which the sealant won't stick to. So that's in that little section there. This is good practice that will allow for that clean tab of sealant, which you can start the peel test with. Finally, I'll say that different sealants may have different criteria for what is considered to be a failed result in an adhesion test. So while we don't want to see adhesive failure generally, in certain applications for certain sealants, this may be allowed. Generally, the sealant will need to demonstrate that it can be extended before for a certain percentage before it fails adhesively. So in this example here, you can see that the sealant has pulled away from the substrate, so it has eventually failed adhesively, but because I was able to extend it and observe that sort of extension before it pulled away, that's still classified as a pass. I'll stress that this is for some applications only. So for example, for structural applications, there is no room for error, so any amount of adhesive failure would be considered a failed test. So consult the specific product technical data sheet when it comes to the failure criteria for a test. Some very simple QA tests for one-part sealants that should be done regularly. So the first is the skin over time test. The purpose of this test is to check the sealant working time and to ensure the sealant cures fully. I'll run through the steps. So start off by spreading a thin layer of sealant up to a couple of millimeters thick on a polyethylene sheet. Glad bags work really great for this. That's what we tend to use for in-house testing. Essentially, you just need a surface that the sealant is not going to stick to. Every few minutes, touch the sealant film lightly with your finger. When the sealant no longer adheres to your finger, the skin over time has been reached. So check to ensure the sealant is skinning over appropriately according to the working time in the TDS. If the time taken for the sealant to skin over is excessively long, that may indicate that the sealant is outside of its shelf life or that it's been stored at an excessively high temperature. Remember, the skin over time will vary with temperature and humidity. So when the temperature humidity is higher, the sealant will tend to skin over and cure faster. Ultimately, you will decide on how often you need to do these tests. We would recommend doing them at least for every new batch number of product that you're using. And remember information related to the test. So the product, skin over time, the batch number, date and time of the test should be recorded in your QA log. Another simple test, which follows directly on from the skin over time test, is the elastomeric test. This is done to check that the sealant is demonstrating typical elastomeric properties. Allow the sealant to cure for at least 24 hours or longer if required. Remove the sealant from the sheet and slowly stretch it to determine whether it is cured to its normal elastomeric properties. If the sealant is not cured properly, or if you see any irregularities, like the sealant is very stretchy or it's brittle, don't use the material and let us know. Again, a record of this test, along with all the relevant details, should be kept in your QA log. Now, finally, in this section, and very importantly, I need to re-emphasize the importance of record keeping. This is your QA log or your daily logbook. Making sure that you're doing the QA test is just the first step. Actually understanding the results that you're seeing and taking the appropriate action when you see something out of the ordinary is just as important. Finally, keeping a record of the QA tests that you're doing and recording important details like the product batch numbers and expiry dates is just as important again. If an issue were to arise on a project or a field adhesion test done at a later point revealed an issue, then you would have this record showing what day the sealant was applied, who applied it, what the batch number was, and so on. And for our own benefit, if an issue was raised to us about a problem with a particular batch of product, we need to know what that batch number is so we can isolate it and investigate appropriately, which is hard to do if there aren't any records kept of it. So we encourage our customers to involve their teams in developing their own QA templates, which work for you and your own requirements. But of course, we have some generic templates which we're happy to provide to assist you with this. In this next section, we will cover information on proper cleaning procedures for porous and non-porous substrates and considerations for the use of solvents. Substrate cleaning is an important element for any successful joint weather sealing application. The key to good sealant adhesion is a clean surface. This is very important and can be very easy to overlook. Some fundamentals to consider for any sealant application are prior to sealant application, surfaces must be clean, dry, dust, and frost-free. Pre-adhesion testing can determine the specific cleaning method for a particular substrate or if a primer is required to achieve adhesion. The point that this photo is trying to illustrate is that even if good adhesion is achieved to the primary sealing surface, as you can see it clearly is, the sealant is sticking to the paint. If the substrate is poorly prepared, in this case where sealant has been applied to loose and cracking paint, then the integrity of the sealant joint can be compromised. Non-porous surfaces are typically smooth and as standard should be cleaned with a solvent before sealant is applied. In a lot of these applications where the sealants will be used, we'll be working with anodized or powder-coated aluminium framing. Solvents have been shown to be very good at removing excess cutting oil, wax, and contaminants on these particular surfaces. And that's what the schematic is showing here, just a magnified cross-section of an aluminium extrusion showing how waxes and oils sit on the surface. The reason I point this out is because it's very easy just to do a simple cloth wipe or wet wipe on a surface. And to the eye, it looks perfectly clean, but in reality, you've still got all these contaminants, which, if they haven't been removed, can potentially inhibit adhesion. It's really important that surfaces are cleaned properly to obtain maximum adhesion. As I mentioned previously, for non-porous substrates, especially, cleaning solvents are typically required to prepare a surface before applying sealant. At Glasscorp, the two common cleaners we supply are 7803 and isopropyl alcohol, or IPA. 7803 and 7805 meet Window and Glass Association testing requirements for cleaning powder-coated and anodized aluminium. So for these substrates, they're used as standard. The difference between 7803 and 7805 is 7805 has a slower flash-off time than 7803. IPA, on the other hand, is a bit less harsh than these cleaners. It's typically used on glass. Some perhaps obvious points, but key points: not every contaminant will be removed by every solvent, so you should consider the condition of the substrates you're trying to seal before selecting a solvent to use. Also, some solvents may damage certain substrate types, and this is another important thing to consider. If you're unsure, it's always a good idea to do some preliminary testing to determine if a solvent is suitable. Okay, I've talked about the importance of cleaning substrates prior to sealant application and the solvents you can use. So now I'll talk about the technique that you should be using. So the two-cloth cleaning method is a proven cleaning technique which we promote strongly for most common sealant applications. This is particularly effective on non-porous substrates. It's super easy. There's just 2 steps. So firstly, dispense your cleaner onto a clean white lint-free cloth. We supply these safety blowback bottles, which make it easy to dispense cleaner and eliminate any risk of cross-contamination. Then use this cloth to vigorously rub the substrate. The solvent will lift the waxes, dirt, and contaminants from the substrate, which will then be held in suspension. The second cloth is used to remove the suspended contaminants from the substrate. So the second step is performed immediately after the first. Taking a new clean second cloth, wipe the surface vigorously to remove contaminants. Check the cloth to see if it's picked up all the contaminants, continuously rotating the cloth to a clean area and wiping down until no remnants are left. A few important points to make here. Solvents must be removed with a dry cloth before the solvent evaporates, or the cleaning won't be as effective. And some surfaces or weather conditions will allow a small amount of residual solvent to remain. And in this case, the surface must be allowed to dry first. So previously I mentioned the considerations to be made around non-porous substrates. So here I'll comment on how best to approach porous substrates. So when we're talking about porous substrates, we're talking about substrates like cement or concrete or stone surfaces. Substrates that have the potential to absorb some amount of liquid. So when cleaning porous substrates, we must assess the nature of the bonding surface. So for example, smoother surfaces like cut, granite, or marble can often be cleaned using the same two-cloth cleaning method you would use for a non-porous substrate. In the photo here, I've shown some concrete brick samples that were pre-applied with a liquid waterproofing membrane. In this instance, the surface finish was very smooth. So I was able to use just a standard two-cloth solvent clean and get very good results. It's important that the substrate you're working with and the surface that you're sealing to is sound, clean, dry, and free from any loose debris or material. You may find that porous substrates with rough or uneven surfaces are difficult to clean using that two-cloth cleaning method, and may instead require abrasion cleaning in order to produce a surface that will allow sealant to adhere. So in this photo, we've got obviously another concrete sample that was provided for testing with a very different quality of surface finish. So the surface on the sample was quite loose and dusty, so I found a cleaning solvent wasn't practical to use here. And I've tried to sort of dust the surface and remove any loose material. Even after adhesion testing, you could see the sealant stuck to the top sealing face, but that layer peeled straight off the substrate. So not a great result. At the end of the day, you'll encounter variations in any substrate that you're working with. And as I said before, we always recommend as best practice conducting a pre-adhesion test in the first instance to establish what cleaning method works best. Finally, in the section, I'll talk about priming. So a primer is an adhesion promoter. Pre-adhesion testing done before the project starts will determine whether adequate adhesion can be achieved by cleaning alone or if a primer is required. Some fundamental principles: apply primer according to the product TDS and make sure you're allowing the required time for the primer to dry and the solvent content to evaporate before applying sealant. While you need to allow a certain amount of time before applying sealant, you also need to make sure you're not leaving it too long either. So, for example, May be recommended to allow the primer to sit for a minimum of 20 minutes to dry before applying sealant. And then you might come back in the next hour or two to apply the sealant. What you wouldn't do is clean a surface, apply the primer, and then come back the next day to apply the sealant. There you're leaving the sealant exposed to the possibility of contamination. And finally, it's important that you don't overprime. So when you see a chalky, powdery residue left on the surface, that may be a sign that too much primer has been applied, or that the primer has expired and is no longer suitable to use. In either case, there's a risk that this will inhibit adhesion and not help it. So for those reasons, and what I've described above, the additional amount of care required when priming, we don't normally recommend it unless testing has shown that it's absolutely necessary in order to obtain consistent adhesion. The primers that are shown here, the three main primers we offer for our Dow sealants. So you've got Dow Primer C and Dow 1200 OS, which are standard for powder-coated and anodized aluminium, respectively, among other substrates, and Dow Primer P, which is used on certain porous substrates. In this next section, we're going to be talking about joint control, gunning, and tooling. Obviously, there are many different types of sealant joints, control joints, expansion joints, butt joints are a few examples, and there may be slightly different considerations that need to be made depending on the specific installation you're looking at. What I'll be covering in this next section are just some fundamentals and underlying principles that should be considered in all types of joint designs. Some fundamentals that apply to virtually all sealant joints. So a minimum sealant depth of 6 mil is required, is necessary to ensure adequate adhesion. So that's your minimum depth of 6 mil. In most cases, a minimum sealant thickness of 6 mil is required to ensure sealant will flow into the joint. So minimum depth of 6 mil and minimum width of 6 mil. There are exceptions to this. But 6 mil is a recommended minimum. 1 part sealants require atmospheric moisture to fully cure, and joint designs need to allow for this. When designing moving joints, the guidelines around minimal sizes should be followed. So that's a 6 mil minimum depth and 6 mil width. Wider joints will allow more movement than narrow joints. The following points also require consideration. Sealants should only stick to the 2 sides that are moving. 3-sided adhesion should be avoided. This can be done with the use of a bond breaker tape, as you can see shown here, or a backing rod. When you have 3-sided adhesion, the movement capability of the sealant decreases significantly, and the joint becomes much more susceptible to tearing, as shown in that top image there. Refer to the product technical data sheet for advice on the maximum joint width as well. Another important consideration for moving joints, and something that we check for when doing on-site testing, is the ratio of sealant width to depth. The width to depth ratio should ideally fall somewhere between 1:1 and 3:1. In most cases, the optimum width to depth ratio will be 2:1. So in other words, a sealant joint that is twice as wide as it is deep. This type of hourglass shape here produces the optimum sealant performance, and this is what we like to see. Some other points: if you're working on filling a large gap, consider the product data sheet for the maximum joint width. So I mentioned that previously. A thin sealant joint will accommodate more movement than a thick joint. So as joints get wider, it's not necessarily better to make them deeper. We say 12 mil is the general maximum sealant depth that you want. If it starts getting thicker than this, it becomes more detrimental than beneficial. And finally, just from a practical standpoint, oftentimes you'll be using backing rod to set the joint size. The backing rod you use needs to be around 25 to 30% larger than the width of the cavity that it's going into. And this just ensures that you get a nice snug fit and it doesn't come loose. This slide here just provides a good illustration of the points I just raised. So in that first scenario there, you have the optimal size joint. So that's a width to depth ratio of 2:1. In scenario 2, in the middle, you have a backing rod that's been set too deep and an overly thick joint as a result. This will mean that it'll take longer to cure, obviously, and there is a great risk of adhesive failure. And finally, in that third scenario, you have a joint that's set too shallow. So a very thin joint, a greater risk of tearing within the sealant. Now we've talked about how to correctly size joints for optimum movement. I'll touch just on the backing rod, which is a key component in a lot of common joint designs. Glasscorp supply polyethylene foam backing rod. It's compatible with most common construction sealants, including the full range of construction and weather sealants that we offer. Backing rod is grey in colour and available in sizes from 6mm up to 50mm. We also supply backing rod applicators, which allow for easy and consistent application of backing rod while limiting the risk of punctures to the backing rod, which is an issue we want to avoid for reasons that I'll discuss in the next slide. Here are some examples of what not to do. So firstly, an issue that's present in both photos, you've got backing rod which hasn't been correctly sized for the cavity it's going into. As I mentioned before, you want a backing rod that's 25 to 30% larger than the gap it's going into. You shouldn't need to twist the backing rod or pack in multiple rods, as has been shown here, in order to fill a gap. This will compromise the integrity of the sealant joint being applied over the top. Also, you should take care to avoid puncturing the backing rod. You can see this more clearly in the first photo here. Puncturing the backing rod can release trapped air, so we call this outgassing. If sealant is applied over the backing rod and the backing rod has been punctured and the air hasn't been allowed to escape, you could get the result of bubbles appearing in the sealant, which we want to avoid. So after cleaning, priming if required, and installation of the backing material, the sealant can be installed into the joint. It's essential that the sealant fully fills the joint opening and the joint is tooled to ensure full wetting out of the adjacent sides. This wetting of the substrate is necessary for the sealant to develop proper adhesion. So here's a good example of a sealant joint that's been fully positive pressure applied, fully wetted out, good adhesion on all sides, compared with one that hasn't. Some fundamentals to consider for sealant gunning and tooling: applying the sealant in a continuous operation, pushing the gun in the same direction that the sealant is being applied. This positive pressure will make it much easier to achieve good joint fill across the width and depth of the joint. After verifying that the joint is completely filled, tool the sealant with light pressure against the backing material. The tooling should be done before the sealant begins to form a skin, so that's typically within the range of 5 to 20 minutes. The use of tooling agents such as water, soap, or solvent, what we call wet tooling, should be avoided. They may affect the properties of the sealant, affect its cure, or potentially have an adverse effect on the adhesion of the sealant. Just a few more considerations to make. Firstly, the application temperature when applying sealant. So consult the product TDS for advice on the suitable temperature range which the sealant can be applied. The sealant shouldn't be applied when it's too cold or it's too hot. When this is done, there's a risk that the sealant can deform if it's subject to a significant rapid temperature change before it's had time to cure and gain its full elastomeric properties. So for example, in this image, the sealant is applied when it's been too hot. So the adjacent substrates have expanded in the heat, meaning the cavity is smaller than it normally would be. and the sealant's been applied, when it returns to normal size or it cools down further, you have an underfilled, overly thin joint. In this opposite scenario, when the temperature has been too cold when the sealant's applied, the adjacent substrates have contracted in the cold. So now you need more sealant to fill that gap. When things return to normal or when it's hot, you've got excess sealant in that cavity, and it's resulting in this sort of bulge effect of the sealant pushing out. Finally, you've got the optimum scenario, so sealant installed at a moderate temperature. That's allowing for the adequate movement, expansion and contraction, as you can see here. Obviously, there'll be times when the application temperature is a greater concern than others. So to give you an example, in the peak of summer, in the middle of the day, on an exposed joint in direct sun, you may want to reconsider whether it's sensible to apply sealant at that time, and perhaps wait until late in the afternoon when the sealant won't be subject to the high stresses and large temperature variations while it's still curing. And finally, in this section, another issue that we want to avoid, and I touched on it earlier, is the presence of bubbles in the sealant. Now, there are a few different things that are known to cause this effect, one of them being the outgassing of the backing rod if it's been punctured. So I touched on that earlier. Other potential factors, as I mentioned, wet tooling agents can contribute to this effect. Joints that are set overly thick may not allow for gases in the cavity to escape. And poor or insufficient tooling may result in bubbles being left in the sealant joint. In this last section of the presentation, I just wanted to discuss some of the points to consider at the end of a project and how we can assist with any testing or compliance requirements. This links back to the items we discussed in the first section. Firstly, we discussed the importance of record keeping and proper day-to-day quality control and testing. Once a project is completed, these QA and project records should be retained. This is for your benefit. As I mentioned in the beginning, if an issue were to arise after the project was completed or an issue was detected during testing, you would feel confident in the work that's been done and you would have those records to go back to. Also, if there's any issue that required investigation or assistance from us, we would be much better positioned to assist with these records on hand. Secondly, if a warranty is being applied for in a particular project, once the project concludes, that would be the appropriate time to provide all the relevant details to Glasscorp to enable us to apply for the warranty. We haven't gone into the details of different warranty types and what's required to achieve them, but again, this is something that's available and something we can offer further advice and support on if required. And thirdly and finally, we often assist with on-site peel adhesion testing, which is testing done on completed sealant joints. And it's sometimes a requirement that will come through from a building consultant, for example. These photos illustrate the details we check for, the adhesion of the sealant to the adjacent substrates, and the dimensions of the sealant joint. The width to depth ratio is something we'll be looking at as I described before. So that covers the main items in the presentation. So we've discussed project management requirements, what you need to be aware of before project starts, the different QA tests for one-part sealants, and the importance of good record keeping, procedures around correct substrate cleaning and preparation, factors relating to optimum joint design and gunning and tooling, and finally, satisfying any post-project requirements. That brings us to the end of the presentation, or the presentation part of the presentation. So thank you very much for your time. I hope you were able to take something away from this. We do have a little bit of time now for questions. If anyone had any to send through, please send those in the chat function. We'll stay online to address those. Otherwise, I'd like to say that we are here to help. So for any of your day-to-day product requirements and general inquiries, your account manager or rep is a great first point of call. And then they might involve me for more involved technical queries or requirements around testing or warranties, for example.